Hello, good morning, good evening, and good afternoon, wherever you are joining me. My name is Shivankar Hazra, and I would like to thank the ISDA Technical Program Committee to give me this opportunity to represent my presentation and research article on dynamic analysis of Windows-based malware using reverse engineering, a case study of exmatter. So, if I want to tell about in brief about it, it's going to be I'm going to do a reverse engineering of malware, and I'm going to find the TTP IOC strings and going to look after the strings which are more vulnerable to the functions which can be used to get admin access to the victim systems, and it will be helpful in gaining insights of how a malware developer is also developing the code, and we can exemplify the system management and getting the access tools to its system. So let's go on with it. This is going to be the agenda of today. I'm going to start with a brief introduction about the malware and how malware works or how malware has been working. I'm going to propose my methodology for this presentation. I'm also going to talk about a bit of background study, what I have done to get to know about this presentation, uh, especially about exmatter malware. Then we will move on to the findings and vulnerabilities that I have found, and I'm going to represent that how actually I have exploited few of the vulnerabilities, and how you can also exploit those vulnerabilities in that systematic manner. Then I will move on with the research scope, and finally I will conclude on how to do more about that. Let's go on. This is a proper definition of malware. I'm not going to read out, you can read it out afterwards. Essentially, it is stating that malware is not only affecting the malicious software, but it has got a lot of ways to come in your system, and it can affect you in very harmful manner. So malware is again a very encrypted data system, so you have to be careful about malware. It can be accessible to anyone, but malware can affect everyone. So it's very important. So always keep your antivirus software EDAVR always on. These are the few types of malware: virus, home trojan, botnet, ransomware, fileless malware, dropware. Out of this, ransomware is one of the most trojanized things that we are using nowadays to pay off the ransoms, or the big companies are being affected by it. So I will move on with, I'm not going to spend my time. So this is my background study. I have done some background study of few researchers, and few research papers also I have learned. So the first one I'm going to actually talk about is the exmatter malware, which are malware, or you can say it's virus or also and trojan employing it. So threat actors have been extorting the victims with this one a lot of times, as you can evidently see that it is not being properly malnutrition. So it will be again and similar terms which we have used. Researchers from Cited Special Operation and Shareable Threat Research. This is again a great article that I read, or you can also read this article. So it was one of the articles that came, I think so, in June 2022. It is a .NET exfiltration tool. So the operations will be done in an appropriate manner. And the threat research team has also found that some of the IOCs and TTPs which have been used for many more functions. The TTPs that were found were mostly used for gaining access via file-based malware, or you can say via getting some type of files such as root files, config files, DLL files, anti-DLL files mostly, because they are very easy to catch calls, and it will be helpful in getting the SIP calls. So this tool was actually for Black Cat ransomware, which is still going on actively, and it is developing daily new types. Daily it is developing new types of attack vectors for it, and the ransomware has been affiliated by multiple ransomware. So you can see that it is not single based. The last point is, it is possible to exfiltrate the particular types of files. So this is just an assertion by me. I won't say only few files. There are a lot of files that can be used. But during my research, I didn't find those many files. So I'm not going to talk about them in detail. So let's move on. Sorry. This is reverse engineering and malware analysis setup. So this was done by me, I was learning about few of the tools and how machine learning can also be compiled into that, but I didn't perform machine learning in that. So the appearance of newly developed black hat network security cracking methods. So this one is using OLEDBG tool. So it is just like IDAPRO and Ghidra. If you don't know about IDAPRO and Ghidra, they are reverse engineering tools. Ghidra is being maintained by NSA, and IDAPRO is maintained by Hexray. So let's move on. Static approach. I didn't use static approach, but I'm just explaining about it. So it mainly focuses on code base. So you have to actually create a code to exploit that vulnerability. So this will be. So I'm not going to spend my lot of time. You can read about it. I have given in references also. So now we move on to experimental setup. So this was my setup. I have used hypervisor guest host OS. So I have used VirtualBox, not VMware. And I have used Remnux for performing reverse engineering of malware. The tools I especially use are Alpha and Cutter. Alpha is very helpful tool for .NET exmatter malware. Oh, by the way, this is actually a .NET malware, which is also an exfiltration tool. So mostly all the vectors are going to be in C# and in .NET. So it's a bit difficult, but it's easy when you learn about C# and .NET. Cutter is also similar to Ghidra only, but it gives a different interface because you can find a lot of different TTPs and IOCs from it, because Cutter gives a bit of difference because it will also give you the endian format of the malware. So you will be able to actually rectify in which form of the hex you are going to be find the exploitable point. So the real-time setup is here that physical machine. I used a different machine for performing malware analysis in which Remnux was set up. There was one Windows OS and there was one Windows Server setup also. So the software required same thing as by Cutter and Remnux VM to perform the malware analysis. Okay, so this is virtual and real time. This is just a configuration file, so I'm not going to go in details about it. You can read about it in slides. So this is my, now I'm going to talk about my proposed methodology. So this is a crafted diagram which I have actually performed. It's not going to be same for everyone. So I have started with capturing the malware. Then I imported the malware in a virtual environment. I already had it in virtual environment, but then I shifted it to Remnux from my virtual OS, Windows OS. Then I performed the malware using both process. It was a bit of dynamic, it was a bit of static. I did some attacks and exploitations also. Then I found that the strings and IOCs. Then I wrote a few of YARA rules, but I'm not sure they are absolutely correct because I'm not that good with it. Then I tried to build a customized malware, and it's not going to be shown in this presentation because it's going to take a lot of time. Then I perform binary addition of two of the files of the malware, and finally I'm going to go after mitigation of the exploits, and then I'm going to finally show you a patch. Okay. So this is a brief introduction of what are strings, IOCs, and TTPs. So this is very much kind of known by the people in cybersecurity space, but in different space I'm going to talk about it. So IOCs are observable patterns of artifacts that point to possibility of hostile activity on a system. So it will tell you about the indicators which are maliciously active. So it is very important to have your EDAVRs on, because it's not going to help if your EDAVRs are not properly on. So these are some types of IOCs, like based on file. It could be on network, it could be on behavior, it could also be based on some of these strings, or it could be also based on some of the copies of strings or some of the functions you have. So TTPs are the methods that are used by the attackers to make their malware more robust and implement the system. Strings are the character and sequence in a binary or executable file referred to as strings. Malware analysis could be any textual data contained in the binary, URL, human readable language, and API function. So it is malware analysis. Strings are similar, that strings will be found out by the reverse engineer or the malware analyst to contain the string and you will be able to find a function and try to improvise that function, or you can make it more difficult for the red team perspective to not able to hack it. So these are few of the IOCs and strings and also some of the methods that I have particularly used and I have particularly observed for this exmatter malware, and also for black hat ransomware, which I am not going to talk about, but it is more of same because it's an exfiltration tool for ransomware, black hat ransomware. So it is going to be mostly same. So I'm not going to read, but you can. So now I'm going to talk about exploit. So what is an exploit? Exploit is actually an method for which we try to actually normally crash the system. Means we try to develop a code, or sometimes we also try to manually exploit that vulnerable code or vulnerable part of that function to gain access to the system via that process. It could be a user access, it could be a root access, it could be a user database access, it could be an SQLite function, it could be MongoDB, it could be a lot of things. So exploit can take many different forms such as code, social engineering of networks, and app development. So these are few I'm talking about. There are lots. It could also be possible to lot of the functional database. So it's critical that people and institutions remain watchful, and people should be aware of that. You should be updating your software and you should be patching it. Patching is a lot of important thing, but most of the organizations do not perform it properly. So it is one of the necessary things. Results. So I'm now going to move on to results. So this was one of the exploits that I implemented for the vulnerability of the authentication event arguments. It just authenticates the arguments of the whole conversion function, and it doesn't have public token, but it will give you an username for username which will be same as the password only, because here you can easily see that it is giving the string username, and you will be able to authenticate for a user by exploiting the credentials, and you will be getting the access to the system. So it is an authentication exploit, but I would also say this is an exploit which the malware has been deployed for its system, so that people will not able to get access to it. This is a buffer overflow. So key hashing. Key hashing is not actually the main part, but it's actually an RSA key algorithm which is actually functionally accessing the system. So the buffer overflow is mostly happening in the red mark which I have done from the in buffer capacity to the public key data.lang. So the overflow is actually trying to manipulate the public key hash and trying to insert its key hash or trying to insert its session key hash, which will be actually not able to get the mark section, and it will be overflowing the algorithmic key. This is RSA key authentication exploit. So the key authentication exploit here is that the invalid operation exception. It is not actually an invalid private key, but it is actually showing invalid private key because when it is trying to perform SSH, the attacker is trying to perform the SSH and it is getting access. So your key will not be more valid. Its key is going to be more valid because it is going to create its own key and it is going to authenticate the system by itself. So it's like if you reboot the system, there could be like a key, and then the author, or I would say the attacker, actually gets the key function. Okay, so cryptographic pairing, I don't know a lot about it, but one of my friend, one of the researchers I was talking, so he told me about it. Cryptographic pairing, the block copy pointer is actually the underflow pointer, because here the actuating size of shipper is actually changing the padding length, and the length size is also input in the offset sentence. So the array length is not going to be the matched up, and it will be actually changing the whole point of function. So the padding will be not as per the functionality, but as per the attacker. So it will help the attacker to block help the attacker to block the length size, and it will be easy for him to actually break the key, and mostly it will be not more encrypted. It will be decrypted very easily. This is the SSH authentication method. So this is very much similar to what I was talking about, the authentication method, but in this section it is getting SSH section header, and and it is getting admin access, or I would say the reverse shell, to the victim system, and it is trying to override the function and maintain the function in that way that the authentication will be done to the victim system, and it will be trying to get the most of our system. So it will be like it will be getting the system authentication, but it will not be able to get the system pro authentication. So it will be getting the authentication in that system and overriding all the function, and we will be getting the SSH. So the success message will not be shown to you, but here one thing I want to talk about that it will be only valid for that session when the attacker is getting the reverse shell. If you are trying to or if your system gets boosted up or your system gets something blocked up and there is a breakage, or I would say there is a blue screen on your system OS, so there is most probability that the SSH will not be happening and it will not get access to your system. So session key exchange, here we are exchanging the key. Public token will not be used here also, but the session key will be another important vulnerability here, because it is getting the session key. So it is one of the important points that the exploit will be made out of it. So the exploit is that it will be like finding out the vulnerability out of the key argument. So it is just disposing the keys and it will be very much helpful. But attacker actually tries to get the session key by just giving out the cookie or changing the cookie format for it, and validating the cookie will also get him the session ID. And if he gets the session ID, then he will be able to access all the files in your system and all the OS interfaces of the system, and even he will be able to uninstall or install anything in your system. Serialization exploit. So this is a Java exploit. So Java exploit, it is exception is there. It is in C#, but it is in Java exploit, serialization exploit. So in this thing, the red part below the set error code -21462333079, it is actually a wrong code database. I would say, because it has manipulated the whole common system ID, and the session will be invoked wrong, and you will be getting an exploit which will be able to bypass, and then you will be actually getting the access to the browsing files, and then you will be actually getting the access to the valid endpoints. In this, I have used the tool CFF Explorer to show you that there is a method allied system. It means that the authentication protocol is working properly, and it will be giving you an authentication like TCP/IP, but in this it is using TLS SSL. So it will be bypassing the whole system, and it will be giving the authentication protocol. So in this section, the public key token is clearly visible, which will be very easy to actually bypass the system again. So this is again something the attackers have done. They have actually rebooted your system to get your decryptor key, and they will be having the decryptor key. Even if you can also have, but you have to do some analysis for that. You should know about it. So they will publicly relocate the decryptor key, but you won't be able to analyze it properly. Overriding the data. So read boolean, read binary, both of the following functions will be lost simultaneously. So these functions will be actually very useful when you are actually going to manipulate the strings, or you are going to know about the enum functions or the static functions which are going to be used in this string. So the pointer functions will give you the string, and it will override the data functions also. So this was the last part. These are the references, and now I would like to thank everyone for giving me the opportunity, and ISDA Technical Program Committee to give me this opportunity to talk about my presentation. Thank you very much.